Hi, I'm Dan Q, and this is the vlog version of my blog post, Beating Children at Mastermind. If you prefer to read the blog version, look around, there'll be a link somewhere, or carry on watching. I swear, I used to be good at Mastermind when I was younger. But now, when it's my turn to try to break the code that one of our kids has chosen, I fail more often than I succeed. That's no good. Maybe it's because I'm distracted. Multitasking doesn't help with problem solving, or maybe it's because this is Super Mastermind, which differs from the one I had as a child in that you've got 8, not 6 peg colours, and the secret code is permitted to have duplicate colours in it. Those two changes alone increase the number of possible permutations of pegs from 360 to 4,096, but the number of guesses you're allowed only goes up from 8 till 10. Or maybe it's I've just gotten lazy, and nowadays I'm more likely to try to solve a puzzle using a computer rather than my brain alone. That's an idea. Let's crack the code by writing some code. The search space for Super Mastermind isn't enormous, and it lends itself to some highly efficient computerized storage. There are 8 different colours of peg. We can express those colours as a number between 0 and 7 in 3 bits of binary. So 0 we'll say is red, and express it as 000 in binary. Orange can be 1, 001 in binary. Yellow can be 2, that's 010. Green is 3, that's 011, and so on. There are 4 pegs in a row, so we can express any given permutation of coloured pegs as a 12-bit binary number. The total search space, therefore, is the range of numbers 0000000000000 through 11111111111. That is decimal 0 through 4095. Whenever we make a guess, we get feedback in the form of 2 variables, bulls and cows. A peg that is in the right place and is the right colour is a bull in our set. That's marked with a red peg. One that is the right colour but isn't in the right place for the solution is a cow, a yellow peg in our set. Of course, you could get 4 bulls, 4 red pegs. That means you've won. Lucky. Any other combination, though, is still valuable information. I want to implement my solution in JavaScript because I want it to run in a web browser on my phone so that I can surreptitiously cheat when I'm playing against the children. The latest versions of JavaScript support binary literals and bitwise operations, so we can encode and decode between arrays of 4 coloured pegs, numbers 0 to 7, and the number 0 to 4095 that represents the guess. Decoding uses an AND bit mask to filter out the requisite digits and then divides by the order of magnitude. Encoding is just a reduce function that bit-shift concatenates the numbers together. With that code in place, it's as simple as producing a list of candidate solutions, that is, an array containing the numbers 0 through 4095. Choose one at random, use that as a guess, and then ask the codemaker how it scores. Then eliminate from the list of candidate solutions all the solutions that would not score that same number of bulls and cows for the guess that was made. Then repeat that process until you win. The most important step there is the elimination. I've made a function getScore which, for a given solution and guess, returns the number of bulls and cows the given guess would score if it was faced with that specific solution. The code looks like this. I'm convinced there must be a more performant way to eliminate candidates from the list, perhaps with an XOR bit mask, but I haven't worked out what it is yet. My solution uses Reef.js for component rendering and state management, and you can try it for yourself. There'll be a link around somewhere. If you play against the online version that I did, you'll need to transpose the colours in your head. My physical version, which I built for, uses pink and purple pegs. The online version I was playing against while testing has brown and black pegs instead. Let's try it out. Let's play against an online version. As expected, my code works well enough to win the game every time I've tried, both against computerized opponents like this and against in-person opponents. Unless you've been actively thinking about the specifics of the algorithm I've described, it might surprise you to discover that my solution is very much a suboptimal one. A couple of test games in, the suboptimality of my solution became pretty visible. Sure, it won every game, but it's a blunt instrument, and anyone who's seriously thought about games like this can tell you why. You know how when you play Wordle, for example, but not in hard mode, you sometimes want to type in a word that can't possibly be the solution because it's the best way to rule in or out certain key letters, yeah? That kind of strategic search space dissection reduces the number of guesses you need to solve the puzzle, and the same is true in Mastermind. Because my solver only proposes guesses from the list of candidate solutions, it can't make that kind of improvement. There are mathematically derived heuristics to optimise Mastermind strategy. The first of these came from Donald Knuth back in 1977. Yes, that Donald Knuth, legend of computer science, mathematics and pipe organs. His solution, published at probably the height of the game's popularity in the amazingly named Journal of Recreational Mathematics, guarantees a solution to the 6-colour version of the game within 5 guesses. Veal, 2013, solved an optimal solution for a 7-colour variant, but demonstrated how rapidly the tree of possible moves grows and the need for early pruning, even with powerful modern computers. But for my purposes, it's unnecessary. My solver routinely wins within 6, maybe 7 guesses, and by nonchalantly glancing at my phone in between my guesses, I can now reliably guess our children's codes quickly and easily. And in the end, that's what this was all about. Beating children at Mastermind. This has been the video version of my blog post, Beating Children at Mastermind. If you'd like to read the original blog post, look around, there'll be a link somewhere. Thank you for listening/watching, and now you know how I beat my children at Mastermind by cheating using my phone.